Hey everyone, my name's Chad. This is a step-by-step guide for Cloudblock, a project that I wrote. Cloudblock supports several different deployment methods, and this video is specific to the Raspberry Pi device for deploying Cloudblock at home. Let's get started. You'll find a link to the step-by-step directions that I follow in the description of this video, and you'll start from the GitHub page. I am using a remote desktop environment on a Raspberry Pi, but you could certainly do this through an SSH connection or a terminal text-only connection to a Raspberry Pi. The first thing I'll do is scroll up to the playbooks directory and then scroll down to the Raspbian deployment. That's the operating system that comes by default on a Raspberry Pi device. We will need to run Raspbian 10, also called Buster or based on Buster, and it needs to be a Raspberry Pi 4. I'm using a Pi 4 Model B with 4 gigs of RAM specifically. I would say a 1 gig or higher would be fine. The previous models, like Raspberry 3s, likely don't support the technologies that we're using to deploy our services. We'll need a terminal, so I'll open one up. And our machine needs to be up to date. So the very first thing you'll run is the update command and then upgrade. This may take some time. My machine is already up to date. It should be pretty quick for me. Yep. And then we'll need to install 2 new packages, Git and Python 3 pip. Both of those are already installed on my machine. I'll keep going. Next, we use pip to install Ansible. All right, and that has been installed. We need to tell our local account in terminal where Ansible's been installed. That's a artifact of using pip to install something. Copy and paste those 2 commands, and then you can verify that Ansible is good to go by typing in which and then the word Ansible. You'll get a response back. Now I'm using the Pi user, and you'll see that it's referencing here the path to Ansible has the word Pi in it. If you're using a different username, you'll see your username there. Next, we need to clone the project and then CD or change directory into the playbooks folder. That's the same folder we're in our browser. Okay, the git clone is done, and you can see we've switched or changed into the playbooks directory. Next, we need to set our variables. At this point, my suggestion is to copy the defaults and open a text editor so we can make changes as needed. So I've got my text editor open, and we'll scroll down in the README to the variables section. First up is the DNS over HTTPS or DO provider. This is where your DNS lookups that are not blocked by the Pi-hole eventually end up. There are several to choose from. My suggestion, do some research about what each one of these providers offers. For example, they may only be available in certain countries, or they may be more focused on privacy than others, or they may have features that you are especially interested in where others do not. It really does help to do a little bit of research, pay good attention to which one you're choosing. I will say OpenDNS has worked fine for me. There's going to be controversy, positive and negative aspects for whichever one you choose. But I'll leave mine with OpenDNS for now. It's been reliable, and that's something that I'm keen on. All right, next is DNS _ no VPN. This is a flag, so 1 for yes, 0 for no. And essentially, it allows your local devices, so maybe a desktop computer or a smart TV, to talk to the Pi-hole directly without using WireGuard. If you set this to 0, only WireGuard connected devices, VPN devices, will be able to use the Pi-hole. By default, it's set to 1. I'm going to leave it as 1. I've got a desktop PC and my smart TV that will definitely need the Pi-hole ad blocking. After that, we've got WireGuard peers. This is the number of peer configurations to generate. There's 1 per device. So if you've got, let's say, a cell phone, a laptop, and a tablet, that's 3 devices right there, right? And that's just for me. If you've got a large family, if you've got some friends that are going to be using your service, go ahead and set it a bit higher. I believe the maximum is somewhere around 250 devices. There's no harm in generating more than you need, though just remember there's 1 per device. So you don't want to mix up your peer configurations. Once we deploy, you'll kind of see this, but you'll have like peer 1, peer 2, peer 3. It would certainly be handy once you've got your peer configurations generated to maybe keep a spreadsheet or a list of which ones you've assigned to which device, just to kind of help you keep track. Make sure you don't overlap. Next, we've got VPN traffic. By default, this is set to DNS. So when you're away from home and your device, let's say it's your cell phone, you've turned on the WireGuard VPN, all of your normal traffic ignores that VPN. You still talk to Netflix, you still browse the internet without using the WireGuard VPN running on your Raspberry Pi that's at home. Your DNS traffic, though, is routed back home, talks to the Pi-hole, and then ads are blocked based on their domain or not blocked, just like a Pi-hole would do. You can change that behavior. So if you want all of your traffic to tunnel back home to the Raspberry Pi, and then go out to the internet from your home internet service provider, and then find its way back, you can change this VPN traffic from DNS to all. And then there is a third option, peers. This allows any of the WireGuard devices to talk to each other. So maybe I've got a tablet and a laptop both connected to the WireGuard VPN at the same time, and my setting here is peers. I could use the tablet to maybe SSH into the laptop or something like that. The other variables, these are all IP addresses. They're an IP scheme for the Docker containers and the WireGuard VPN subnet. You'd only really need to change these if you're planning out additional networks or you have existing networks that would overlap. For all of the Docker variables, we use 172.18.0.0/24, and for WireGuard, we use 172.19.0.0/24. The CIDR notation isn't needed, it's hard-coded as a /24. All right, all of these have been set. I suggest keeping a copy of this, especially if you've changed anything. I kept mine. You know what, I'll change one. I'll change my peer configurations to 20. All right, so keep a copy of this, maybe make a copy, have a backup, just so you know what settings you set. And whenever you do updates, perhaps in the future, if you need to update the Pi-hole, it's good to have this as a reference, instead of trying to memorize the settings that you use the first time around. All right, what's next? Let's scroll back up to our instructions. So we've set our variables. We need to paste all of these into the command line. All right, they're all pasted in. And then we have the option. We can either have a Pi-hole password for the web UI generated automatically, or we can set the password ourselves. And this right here are options to set it ourselves. I'm going to do that. I'm going to set one myself. So we just need to run a couple things. First, we make a directory. Then we set the password. You'll want to change some password to whatever password you want to use. I'm going to change mine to some password 1. Hit enter. And then we set that file. You can see it at the end there, /opt/pi-hole/ph_password. We set restrictive permissions to make sure it's not readable. And next we run the Ansible playbook. This is a long command. Make sure you grab the whole thing. Copy and paste. This will take some time, especially since this is the first time we run it. There are packages that need to be installed. Okay, we have the output from the playbook. You can see it here, the playbook summary. Let me hit back and go down to the step-by-step guide. And there we go. See playbook summary output for the web UI and the WireGuard client files. And we've got them here. If you're local, like I am on my desktop, you can use this first URL. Oh, and before we get started, I would suggest you copy this and maybe paste it into the same file where you're keeping your customized variables. So you've got both of them together as a reference. You know, keep that somewhere safe, maybe keep a duplicate copy. All right, and let's take a look. So we've got our web UI. I'll grab this URL. The one thing I'll note also is we can make sure the containers are all running. They are. I ran sudo docker ps, and what I was specifically interested in is this healthy for the Pi-hole here. Pi-hole, especially on the first time it's generated, takes a couple minutes, maybe a minute, maybe 2 minutes to initialize everything. And I wanted to make sure it was good to go before we continue, and it is. So I'll grab that URL, paste it in. Your connection is not private. That is expected. The error message specifically is the certificate authority is invalid. That's because we're running a web proxy, and you can see that mentioned here. We put a secure web proxy in front of the Pi-hole web UI to secure it with HTTPS or TLS. So we actually want this error message. It's just because we're using a self-signed certificate. We hit proceed, and then we can log in. This is the password we set either manually or we allowed the Ansible playbook to generate for us. If you allowed Ansible to generate it for you, run sudo cat and then the file path. Mine I set manually, it was some password 1, but I'll type it in. And now the Pi-hole can be customized as desired. The one thing I'll note about these settings, specifically, if we go to settings and then DNS, the 2 upstream DNS servers are the Cloudflare D DO container. So these 2 IP addresses, I don't suggest changing. They're the same value, but I don't suggest changing them. Pi-hole talks to this container, Cloudflare D DO, to update. So the Pi-hole talks in standard DNS, unencrypted, and then this container will encrypt those DNS requests and send them off to our DO provider. Mine was OpenDNS. So I don't suggest changing these 2 values, otherwise you may end up breaking the DNS over HTTPS, your encrypted DNS. Otherwise, go ahead and make changes as needed. What else do we have? We have so let's go back to the output. We had DNS no VPN set to 1. I could go into my router now and change the router to use this when it hands out DHCP IPs and DNS settings. I could set the DNS to this IP address, and then I've got ad blocking built in to my home network. There's one more step involved in that, and I'll mention it now. We should. If I scroll down, if your Raspberry Pi, so the server itself, the little machine, is using DHCP and it gets its DNS from your router, you would potentially end up with a loop. So if you set in your router that your DHCP clients get a DNS server that points to the Pi-hole, and your Raspberry Pi gets its DHCP and therefore DNS from the router, you've somewhat created a loop. and we need to decouple that. So this is only if your Raspberry Pi is using dhcp, but we can make the change. So it's very straightforward. It's a set of 4 commands. The very first one is we want to back up our dhcp client configuration. I'm going to paste that in. It's now backed up. Next, we need to disable DNS via DHCP. So this tells the Raspberry Pi, when you get a DHCP IP address, ignore the DNS server that comes along with it. All right, that's done. And then we can hard code a DNS server in. So this tells the Raspberry Pi, don't use whatever DNS you have by default or that you get via DHCP. Always use this DNS server. This helps break that loop. It allows all your other clients on your network to use the Pi-hole, but the Raspberry Pi specifically is the exception to that rule. It will use a different DNS server. Keep in mind, the Raspberry Pi itself will have a different DNS server, but you can set it to whatever you'd like. By default, it's quad 1 or 1.1.1.1. You can see that value here. Change it. If you've got a different preference, go ahead and change it. I'll hit enter. And then finally, you'll need to, if your Raspberry Pi is wireless, you've got one command. If your Raspberry Pi is wired, you've got another. Mine is wireless. I'll go ahead and run it to show what that looks like. I am using RDP. I'm remote desktop into the Raspberry Pi, and I'll lose my connection to it momentarily. So it's unresponsive for a brief second, but once the command is complete, I should see it come back up. The same could be said for an SSH connection. Give it just a few seconds. It's already back. It's good to go. And I'll hit enter just to make sure. Yeah, it's done. All right, so we've broken that loop. We don't have to worry about that. The Raspberry Pi itself, the operating system, will use a different DNS to break the loop. Let's scroll back up. Oh, what's next? So we've got the web UI. We can make changes. If you're on the VPN, if you're on the WireGuard VPN, there is a different address. You'll want to keep that in mind. And then we mentioned on your router, you can go ahead and set this for your local DNS. I should also mention, if you are using DHCP on your Raspberry Pi, it's important to make sure you've got like a static lease set up, right? So on my router, for example, I can say this MAC address, the MAC address of my Raspberry Pi, should always get this DHCP IP address. And I have that set. Mine is 192.168.0.7. So what I ran was I did this. I typed in IPAD. Let me show that again, IPAD. I found there's quite a few things in here, especially with Docker. I found my wireless LAN, and then I found the MAC address, and there it is. So there's the MAC address of my Raspberry Pi's wireless LAN interface. In my router, I set DHCP to always give that MAC address this IP address. And that way I don't have to worry about my DNS server IP changing. Keep that in mind. Okay, let's resize this window. Next is the WireGuard configurations. So these are all the configurations for each one of the clients. Remember, I set mine to 20, 10 was the default. Always make sure you have more than you need. You can see that they've been generated with this command. Paste it in. And there we go, we have 20, right? They're a little bit out of order because of the way numbering is, but you can see there are 20 configurations. And inside each, they're folders, there are 20 folders, and inside each folder there are 4 files. The important bits are the .conf and the .png. .conf would be used for things like a Windows machine or a Mac, where you need the text configuration, and then the .png is a QR code that an Android or an iPhone phone or a tablet can scan with their camera to import the WireGuard VPN configuration. So let's take a look at those. Let's take a look at, I'll do peer 20. And if we look at peer 20.conf, we can cat it, and you can see the configuration. So this is what would go inside the, you can import it into a Mac or a Windows WireGuard VPN client. You can add it via text. And then there's the PNG. So we could look at that with the File Explorer. If I go to opt WireGuard, and then I'll click peer 20, we'll stick with that one, and then peer 20.png, and there's the QR code. So I have the WireGuard app installed on an iPhone or an Android. There's an option, add WireGuard VPN via QR code scan. I click that button and then point my device camera, and it imports the WireGuard configuration. Now remember, keep in mind, peer 1, you probably want to make a list. So peer 1 could be my cell phone, peer 2 could be my tablet, peer 3 could be my laptop, and so on and so forth. Don't mix them up. You don't want to have two different devices use the same peer configuration. If you're in a text environment, text only environment, like the CLI you're SSH'd in, and you need the QR codes, there's an additional option. You can run sudo docker logs WireGuard and see the QR codes in a text representation. I think this is really cool. So let me run that command. And if I scroll up, there is one of the QR code. There's peer 20. And then above that would be peer 19, and so on and so forth. So you could also, instead of using the PNG files, you could scan these with your phone too. Really cool. All right, so that about wraps it up. You've got Pi-hole, edit it to your heart's content. You've got WireGuard, you can use that remotely. A couple things to note. And if we look back at, I want to look back at the text. So you'll notice a couple things here. Listen port 51820, that needs to be open on your router. So I've went into my router and forwarded or allowed port 51820, it is UDP, not TCP, to my Raspberry Pi IP address, and that is 172. That is, if I type in IP add grep 192, that is this. So in my router, if I look at my firewall settings, I've got port 51820 UDP forwarded to this IP address. That's needed for WireGuard clients to be able to reach it internally. And then on top of that, there's also my external IP address. We didn't set this anywhere. WireGuard figures out your external IP address. And then when you're remote, that's how your devices call home to WireGuard. They need to know your home IP address in order to call home. If your IP address ever changes, you can edit the client, whether it's your phone, a Windows device, a Mac, you can manually edit that IP address. But you need to know that. So if you've got an ISP that hands out dynamic IP addresses, you'll need to keep tabs on your home IP address, maybe use a dynamic DNS service so that you always know what your home IP address is. Keep that in mind. I have, and I will say this, the experiences vary between folks. So I have my home IP address, I can change it as necessary, and it is DHCP, it's dynamically assigned to customers. My IP address, though, hasn't changed in a significant amount of time. I haven't changed it, and my provider hasn't, but it does occasionally, right? I've had the service for over a year, and I think it's changed one other time. Some other folks, they've said it changes every couple weeks, right? Or every few months. And then there are some that have a static IP and it never changes. So experiences may vary. If you've got a home situation, a home ISP situation where your IP address is constantly changing, or your ISP uses carrier grade NAT, CG NAT, you may want to look at running this in the cloud instead, where you can use a cloud connection to give you the Pi-hole blocking. when you're away from home. Look at Oracle, look at Google Cloud. If money is a concern, they should have always free options. In fact, all of the cloud providers have some sort of free or at least limited time offer. Oracle and Google Cloud have always free tiers, at least at the time I'm making this video, where you can run indefinitely this service in the cloud. That may be useful for you, or even do what a lot of folks do as well, is run a hybrid approach. They'll run this at home, and then they'll have Cloudblock running in a cloud provider as either a backup or a secondary service or a service for when they're away from home. All of those options are really good. There's no one situation that fits everyone, so maybe customize the deployment. If you have any concerns or questions, or maybe you're not sure which method to use, my suggestion, join the Discord channel. I'll put a link in this video and we can chat about it. We can figure out what works best. There's plenty of folks in there now. Everybody's been sharing ideas, sharing their experiences. We've had plenty of troubleshooting sessions. Feedback's welcome, ideas are welcome. More than happy to help you out. All right, and then the final thing is updates. So occasionally Pi-hole, and especially if you're familiar with Pi-hole, you'd already know this, but Pi-hole will have updates. On top of that, WireGuard will have updates as well. And then there are two more, the Cloudflare D service, which translates DNS into encrypted DNS, and the web proxy. All four of those occasionally get updates. My suggestion, instead of going crazy and trying to keep up with all four of those getting updates, my suggestion is to keep an eye on the Pi-hole service, and whenever it gets an update, maybe update all of them. There's not really any additional steps that you need to take. You could just use that as the trigger to update all of your containers. And I'll show you how to do that. That's in the README. So we scroll down, there's this FAQ section. Actually, I don't know if it's in the FAQ section. Oop, I scrolled down too far. Do I need to refresh? Oh, here we go. How do I update my Docker containers? So I put this first bullet here, review the Pi-hole and WireGuard container update instructions, because they're not your typical instruction. If you've run a Pi-hole before, you know about the up or update command. Pi-hole specifically, when running a Docker container, is you do not update it that way. You do it differently. And Cloudblock, this deployment, this code, this Ansible playbook will do it for you. It's fairly straightforward. My suggestion is read how the Pi-hole developers suggest doing it, and then also know that Cloudblock or the Ansible playbook does it the way that they suggest. So we're okay. The very first thing we'll want to do is be in. So let's assume that it's been a month or something along those lines, or there's a new update and there's a feature you want and you need to, and you're interested in testing or having that feature. So I'll close out of my terminal and start fresh. So, okay, there's a new update. I'm really interested. I've got my README, I've got my notes, right? We kept a copy of those, and we've got our terminal open. Very first thing is go to the Cloudblock playbooks directory. Update Cloudblock, so maybe I've updated some code or fixed a bug. There we go, there was one file changed, I changed the README. And then set your customized variables. You can use the ones you've saved. Exactly what I'll do. Paste it in. And then let's scroll down. We've removed the old containers. The service is down until Ansible completes. So this command will remove all four of the containers. Cloudflare D, that's our DNS to encrypted DNS, the Pi-hole, the web proxy, which gives us encrypted to the Pi-hole, and then WireGuard, the VPN. So we'll run this. Oop, I missed the S. Let me grab the whole command. Copy and paste. This will take just a second, and it's done. All right, and then we can rerun the Ansible playbook. When we rerun this playbook, it will grab the latest version of all four of those containers, but it will keep the data that we had. So for example, the peer configurations for WireGuard, those won't change. Those already exist on our machine, and we didn't remove those when we removed the containers. If I look at opt/opt, we can see the folders, and WireGuard in particular and Pi-hole. Those two have long-term data. Pi-hole has things like our customizations. If you added an additional block list or white list, if you set up groups or additional customizations, they're in this folder, and we didn't remove this folder. The same thing with WireGuard. The WireGuard configurations, we didn't remove those. If we've removed this folder, we'd have to re-import our WireGuard peer configurations to all of our devices because we'd have new peer configurations. So we haven't done that. We're just updating the code of the container, and then those containers will pick up these directories when they start up again. So I'll paste the ansible playbook command. It shouldn't take as long this time. It still does need to build the Docker containers, but a lot of the software that we needed has already been installed. Either way, let's give it a minute. I'll be back when it's... Okay, we have the playbook summary. It's essentially the same as what we had before. And all of our containers have been updated. So if I run sudo docker ps, we can see they were created, there we go, 30 seconds, 49 seconds. Everything's been started back up with fresh container. That about wraps it up. Again, Discord, if you want to discuss this with others, if you've got questions, comments, ideas, all feedback is appreciated. You can also reach out on GitHub. That's fine too. GitHub issues if you found a bug, pull requests if you want to write some code and contribute to the project. All of that is appreciated. Thank you very much and have a great day.